LoCHAid, an affordable DIY hearing aid. The Gennaris Bionic vision system is a step ahead of Neuralink. And finally, mindful meditation improves the ability to control a brain-to-computer interface. Stick around to find out more in this episode of News Bytes. Hello and welcome to Advanced Ingenuity Labs, your insight into technology. I'm your host, Aisha Sharif, and this is News Bytes, where we cover innovative developments in the latest technologies. According to data from World Population Prospects, the 2019 revision, by the year 2050, 1 in 6 people in the world will be over the age of 65. Which is up from 1 in 11 in 2019. The number of persons aged 80 years or over is projected to triple from 143 million in 2019 to 426 million in 2050. With this aging population growing, so are healthcare needs. One such example is age-related hearing loss. This need came to the attention of Saad Bomla, a bioengineer, when he was attempting to purchase a pair of hearing aids for his grandparents. He realized that hearing aids were not only priced outside of his budget, but that they were also unattainable for a large portion of the global population. Bomla wants biomedical devices to be as cheap and accessible as other consumer electronics. He still remembers the shock of learning that he couldn't afford to help his grandparents. He recalls, "I thought owning a laptop and a cell phone meant I had the means to buy hearing aids. But then I realized how expensive they were. It was sobering." He set out to invent a device to help not just his grandparents, but grandparents around the world. He created the LoCHAid, a do-it-yourself hearing aid made from inexpensive, easy-to-find parts. The no-frills device could help restore hearing to millions that are suffering from age-related hearing loss. The LoCHAid hearing aid has been developed by researchers from Georgia Institute of Technology, and it looks to be a promising step to making hearing aids an affordable option to almost everyone suffering from age-related hearing loss. This would make a drastic difference, as only about 3% of adults over the age of 65 that are suffering from hearing loss in low to middle income houses can afford hearing aids, which can cost anywhere from $1,000 to $8,000. Part of the extremely high cost is attributed to the fact that hearing aids are more than just amplification devices. Hearing loss happens at different frequencies, so boosting all sound won't work, and as a result, may make hearing even more difficult. The research team decided to just focus on age-related hearing loss, because older adults tend to lose their hearing at higher frequencies. Focusing on this group allowed the team to simplify LoCHAid's design and narrow down the range of sound frequency needed. Modern hearing aids use digital signal processors to adjust sound, which are power-hungry and expensive. LoCHAid uses electronic filters to shape the frequency response. And this is a cheaper option and was used in hearing aids before processors were widely available. The LoCHAid is a modular hearing aid which can easily be made using mass-manufactured components. These include an electret microphone with an automatic gain control and preamplifier, a Class D stereo amplifier, a frequency filter, and a standard 3.5mm audio jack. Creating the device is quite easy, and it only requires some basic soldering skills to get the job done. The device uses a custom circuit board and only requires a few soldering points. Overall, it takes about 30 minutes to complete the project. To make the device more compact and user-friendly, a 3D printed case has been constructed to contain the device. The price to mass-produce LoCHAid is a remarkable 98 cents, cheaper than a bottle of water. However, if you wish to make one at home, it'll cost closer to $20, which is still drastically more affordable than current hearing aids. It does seem that these hearing aids could require replacement over the course of a year or two, but even if you had to replace your LoCHAid hearing aids annually, it would take you 500 years to reach the price of the cheapest low-end hearing aids. At Advanced Ingenuity Labs, we appreciate and congratulate Saad Bamla and his research team for identifying a need within our global community and providing a solution that is not only practical and affordable, but also innovative and inspiring. Let me know what other age-related conditions you feel can benefit from assistive technologies. If you enjoy this video and find value in our content, you can help us by sharing it with others. Also, leave a comment as we want to hear from you, and consider liking the video and subscribing to our channel. You may also click the notification bell if you don't want to miss our upcoming videos. To stay informed about our upcoming training courses and camps here at Advanced Ingenuity Labs, visit our website at advancedingenuitylabs.com and sign up for our email notifications. Earlier this year, with the pageantry and media coverage we've come to expect from the billionaire founder and CEO of Tesla and SpaceX, Elon Musk introduced the world to Neuralink. As Musk explained, many neurological problems such as memory loss, depression, blindness, seizures, etc., are the result of electrical signals in the brain firing improperly. The Neuralink is an implantable device that directly interfaces with a person's brain, reading signals from the brain and even altering them. While the Neuralink performs as promised, the technology it's using is not necessarily new. Neuroscientists have heard the pinging of animal brain activity in their labs for decades. Research and development of brain-machine interfaces dates back to at least the 1970s. In addition to Neuralink, researchers around the world are making great strides in restoring vision to those suffering from untreatable blindness. Without the media attention or the accolades from the general public that Neuralink received, scientists in Australia, who have spent more than 10 years developing a first-of-a-kind bionic vision system, are now preparing for human trials. Researchers at Monash University in Melbourne have created a system that interacts directly with the surface of the brain and has the potential to restore human vision. Clinically blind patients often have damage to the optic nerves, which blocks signal transmission from the retina to the vision center of the brain. The Gennaris Bionic vision system is built to carry out the function of healthy optic nerves. The university's innovation and technology will not actually replace the eye or be directly implanted into the eye. Instead, it will require headgear that wraps around the head. The system aims to bypass the damaged optic nerves with this special headgear, which includes a built-in video camera and wireless transmitter, a vision processor and software, and a set of 9x9mm square tiles that are fitted with hair-thin electrodes, which are implanted into the brain. This complex circuitry is capable of turning the collected data into electrical pulses that stimulate the brain. These electrical pulses stimulate the brain in a way that creates visual patterns, combining as many as 172 spots of light, which will allow users to navigate both indoor and outdoor environments and also be able to recognize people and objects within their vicinity. According to the director of the Monash Vision Group, Professor Arthur Lowry, the way the tiles are arranged offer a wider coverage of the brain, and this is key to the huge potential of the device. And this is what separates Gennaris from other bionic vision systems that are currently under development. Professor Arthur Lowry further explains, our design creates a visual pattern from combinations of up to 172 spots of light, phosphenes, which provides information for the individual to navigate indoor and outdoor environments and recognize the presence of people and objects around them. Following a successful trial in sheep, where 10 devices were fitted in the sheep through a purpose-made insertion system, the device performed more than 2,700 hours of stimulation without any observable adverse health effects or damages to the animal's brain. According to the team, this was one of the first long-term tests of a fully implantable cortical vision prosthesis in the world, and the device was well tolerated by the brain tissue without any adverse health effects. The university's Cortical Frontiers project is now preparing to start clinical trials in human patients. The researchers say its potential might soon extend beyond helping restore vision in people suffering from untreatable blindness. With the bionic system moving into clinical trials, the team is hopeful that it could be a cure for ailments other than blindness. They are eager to explore how the system could possibly treat spinal cord injuries, epilepsy, depression, and a number of other conditions. We've all heard about the need to unplug from time to time, and now a study from Carnegie Mellon University recommends it. We all rely on our electronic devices for work, school, socialization, and entertainment on a daily basis. But ironically, it seems the best way to control a brain-to-computer interface is to meditate beforehand. Ben He and his collaborators at Carnegie Mellon University conducted a large-scale human study, with each participant being randomly assigned to either the meditation group or the control group. After the subjects in the mindfulness-based attention and training group completed their training course, they, along with the control group, were tasked with learning to control a simple brain-to-computer interface system by navigating a cursor across a computer screen using their thought. This required them to concentrate their focus while visualizing the movement of the cursor. During the course of this process, Ben He and his research team monitored their performance and brain activity using EEG. The study showed that with just 8 lessons in mindfulness-based attention and training, significant advantages were achieved when compared to those with no prior meditation training in both their initial ability to control the brain-to-computer interface and in how long it took them to achieve full proficiency. These findings are extremely valuable for the process of brain-to-computer interface training and the overall feasibility of non-invasive BCI control using EEG. This study shows that even with just a little mindfulness-based attention and training, most subjects will be able to make noticeable improvements in their ability to control brain-to-computer interfaces. Ben He explains, meditation has been widely practiced for well-being and improving health. Our work demonstrates that it can also enhance a person's mental power for mind control and may facilitate broad use of non-invasive brain-computer interface technology. That's it for this episode of News Bytes. As always, if you enjoyed this video and want more, leave me a comment and consider liking and subscribing. See you next time.